Module 1, Section 6, Objective 4. Evaluate square roots of perfect squares. Okay, perfect squares are a limited number of square roots, but there are square roots of any number, and I'll explain a little bit more about that here in a sec. Okay, we got a blank page here for just a second. We have inverses in math all over the place. Okay, so the inverse of add is subtract, right? And the reason for that is you check an add problem by using subtract. Okay, so the inverse of add is subtract. The inverse of subtract is add because you check a subtract problem by adding. The inverse of multiply is divide, and we'll get that in a future section. And the inverse of divide is multiply. Okay, but for this particular thing, the inverse of squaring something is the square root of something. Okay, square root looks like a little check mark with a line across it. Okay, that's technically called a radical, but you don't use that in saying any of this. You need to know what it is, that name, this is a radical, but if there was a 4 under it, you wouldn't say radical 4. You would say square root of 4. Okay, so let me show you something else with this, and then we'll go back and do a few problems on the other page. Okay, so 3 squared is 9, right? And now to double check this, we need to go backwards. So you would write that as the square root of 9, and that is 3. Okay, the radical, that check mark line thing, means what number times itself gives you, and then the number underneath. So in this case, 9. What number times itself gives you 9? 3, because 3 times 3 is 9. This one. What number times itself gives you 4? And the answer to that one is 2, since 2 times 2 is 4, right? 2 2s. And this one down here at the bottom is 2 3s. Okay, let's go back to the other page. Okay, so they just explained what I did on that other page. The inverse operation of squaring is what square roots are. So 4 squared is 16, therefore the square root of 16 is 4. You just work backwards. And you write it this way, using the radical. And you ask what number multiplies by itself to give you the number under the radical. So what number times itself gives you 9? And the answer is 3, because 2 3s times together give you 9. What number times itself gives you 36? It is 6. What number times itself gives you 100? It's 10. Okay, over here on the other side, what number times itself gives you 64? And it's 8. What number times itself gives you 4? The answer is 2. What number times itself gives you 1? The answer is 1. What number times itself gives you 25? The answer is 5. And last one, what number times itself gives you 81? That's 9. Okay, these are called perfect squares because your answers are all whole numbers. Okay, back over to our blank page here. That's going to be blank again. Here we go. Okay. If we had the square root of 4, we know the answer is 2. The square root of 9, the answer is 3. Because 2 2's give you 4, and 3 3's multiplied together give you 9. There are all the numbers in between, but because this is a whole number and this is a whole number, all of these numbers in between are going to be decimals or fractions. So we'll get to those in a later unit. For now, we just want the ones that work out evenly.